Hi everyone. So this is my first assignment of fluid mechanics, understanding fluid properties and their engineering applications. So my name is Sanjay Tyagarajan, and my matrix number is 231339. Okay, so first of all, introduction to fluid properties. Okay. The importance of fluid properties in engineering systems. In systems like pipelines, aircraft, and medical equipment, fluids play a critical role. The way fluids behave, whether they are flowing through tubes or forming droplets, directly impacts the performance and safety. So, understanding key fluid properties like viscosity, density, and surface tension helps us design more reliable and efficient systems. So, key fluid properties. There are three key fluid properties I'll focus on are viscosity, density, and surface tension. Okay, viscosity is the resistance of fluid to flow. Density is the mass per unit volume. Surface tension refers to the force at the surface of a liquid that affects droplet formation and flow behavior. All three are essential in understanding how fluid interact with their environment and in engineered systems. Okay, so engineering applications all over general. So let's look at how these properties apply in engineering. In all pipelines, high viscosity increases the energy needed for pumping. In aviation, fuel density affects weight distribution and balance during flight. In biomedical devices, both surface tension and viscosity influence how drugs are delivered and how blood or samples move through small channels. Each property plays a critical role depending on the system design. So this is my real world application. So the real world application that I chose is design of a perfume spray nozzle. This system relies heavily on fruit properties. The goal is to create a fine mist that spreads evenly and smells pleasant. This involves a very careful balance of viscosity, density, and surface tension, just as the key fluid properties in the before slide. So, this is the design conflict. Low viscosity improves spray flow but might cause inconsistent droplets. High surface tension helps with neat droplet formation but restricts spray spread. The density of the liquid also affects how the mist disperses. So, designers must balance these competing fluid properties perfectly. So, this is the engineering solution to overcome the challenges and the conflict that engineers use three strategies. First, they optimize the perfume's fluid formulation to get the right balance. Second, they control the temperature since it affects viscosity and surface tension. And third, they design the nozzle geometry to produce a consistent and fine mist. Okay, so we came to the end of the session. Conclusion. In conclusion, fluid properties like viscosity, density, and surface tension are fundamental in engineering. The perfume spray example shows how these properties interact in real world design. Ultimately, engineers must make trade offs to achieve the best performance, balancing ideal fluid flow with practical outcomes. So that's all from me. I'm Sanjay Tyagarajan. My matrix number is 231339. Thank you so much.